First of all, when you check out this code, you will see that there is a root folder. There's a main parent project, which is a Maven project. As you can see, there's a pom.xml file, right? This is where you define your artifact and its version, and connect it to GitHub, the SCM. You are going to specify what modules, its child modules. You will specify the repositories, your build plugins, code formatter, and any properties you may have. Now, out of the box, you don't have to change much in this file. In the MDRTB module, you will see a much beefier file. There are plenty of more dependencies, but I will just talk about a few things over here. The group ID has to be org.openmrs.module. That's rule number 1 to define that this is an OpenMRS module. Artifact ID is your module's name, right? And then if you want to give a fully specified name and description, this is where you put it. Now, SCM is where you define your Git repository. This is something optional, you don't have to do it. Then there's modules, I'll come back to it. And then we have repositories. Repositories are the sources from which your dependencies are downloaded. So Maven has to know where your dependencies exist on the internet to be able to download them. Now you will see 3 different repositories. There is the Maven Central over here. This is Maven's default repository. Then the older OpenMRS repository, which was on Maven Nexus, and then OpenMRS migrated to JFrog Artifactory. This is the link to OpenMRS's JFrog repository, right? So these are the 3 sources from which the dependencies, the jar files, are going to get downloaded. Now, moving on, you have a plugin for compiler. So this is Maven compiler. When you compile using Maven commands, this plugin is used, and I have explicitly told the plugin to use Java version 1.8. Similarly, in the properties as well, I am telling the module to use 1.8 as source and 1.8 as target. So the code is going to be compatible with Java 1.8, and the output, the build files, the Java classes are also going to be in version 1.8, right? Then I am also adding some more properties. So this one is saying WS REST version. So REST web services, which version is actually required at least for this module to work. So this line is basically telling you that there has to be a dependency over the REST module. And then this is also defining OpenMRS's platform modules, which is 2.1.2 right now. It's quite old, but still not completely phased out. It's still version 2x. So these are a few things to notice. And here we have a code formatter plugin, which formats the code according to OpenMRS's own formatter. And that's pretty much it to the POM file. If everything is fine over here, you're going to run this command maven space clean space install, and then skip all the tests, skip tests with the skip test switch, and it should compile fine. I am unable to run it because the tests are failing, and that's fine. That's not something wrong with the code per se. Now, after exploring POM file, you will see that there are 2 more sub projects within this main Maven project. So this is basically a parent project, and it has 2 modules. One is API module and the other is OMOD module. This is a standard for OpenMRS projects. You have to have these two different projects set up. One is for API, the other one is for POM. Right? Now I will jump to one file in particular. Yes, in OMOD. In the OMOD module, I'll explain in a bit what these two are. That's basically when we were discussing the anatomy of an OpenMRS module. That's where this is coming from. Actually, let me just go ahead and fire up the PowerPoint, the presentation as well. Okay, so it's important to understand why these two modules exist. Okay, see, this one OMOD module packs two different sub projects inside it. There's the API and there's the OMOD. API deals with the DAO, all the interaction with database using Hibernate, and implements all the service layer functions. So you have the model. First of all model classes are going to be here. The entity classes reside over here. The main service is here. The DAO, the repository, the data JPA repository is here. You will define constants over here. You will add utilities inside API. So API is what you can say the brain. Then you have OMOD. OMOD's main job is to provide the web services. API is internal to the module. None of the API's functions are exposed to OpenMRS when you deploy the module. OpenMRS talks with the OMOD part of the module. Now OMOD is where you are going to write your REST resources, all the endpoints. This is where all the Spring controllers reside. This is where you write all the JSP pages. The messages.properties file also is going to be put here, and the module's manifest file. This is what the OpenMRS or any external system talks with, not the API directly. So this is for business logic. This is for your web exposure. These two modules make up one OpenMRS project, one OpenMRS module. Now let's talk about this file called config.xml. This is manifest file, and the most important file to understand in a module when it deploys, what it controls. So you can see what this file is doing is, first of all, it's reading the module properties from the POM file. So the parent artifact, the name, the version, all of this is exposed to the web, because see, web does not know what your OMOD file is, what this project is. So you have to provide that information to expose this information over your REST layer, right? This is one. Then you have certain requirements mentioned. This part, require modules. This is where you define all the module dependencies. As I explained in my in our workshop day 1, that OpenMRS modules may also depend on other modules. So what this XML tag is telling you is that in order to run CommonLab module, you have to have WebREST module, web services.rest module installed. and exactly which version. This is coming from the POM files properties. Here I have defined version 2.17. This is used as reference over here. So if this module is CommonLab module is meant to be run, you need to install at least 2.17 version 2.17 of the REST module. This is where you define dependence, and this is just one of the modules. You can have a whole list of other modules as dependencies. Then you have extensions, so-called extensions. What this is telling you is you have on your admin page, there's, when you launch OpenMRS, let me just go to this one. You see in admin page, you are going to see these CommonLab test and managed test types. So these two links are coming from over here. In the config manifest file, we are telling OpenMRS that our module is going to have certain pages which are meant to be populated on the admin page. So in admin list, you are going to provide this list. This list resides in the OMOD file. We'll come to that later. Then there's another extension. This extension is telling us that this module's information is going to be shown on patient dashboard. Meaning when you search for a particular patient, say Abdul Basit, right? This lab tests part, this page, how does OpenMRS know that some module is trying to load a section of its information into the patient's dashboard? This is where you define that extension. So OpenMRS patient dashboard tab, this is the dashboard part where we are populating our CommonLab test extension. You will see this in this extension. So both of these extensions are defined in the OMOD classes extensions. This is giving you two different pages, right? There's manage lab test types, then there's manage lab test attribute types, right? These two forms are going to be shown on the admin one, and then this one populates what? The lab tests for on the patient's dashboard. I'm explaining all of these to be for your understanding of how the module works out of the box, even though you may not be interacting, making any changes to these portions. Then there is this aware of extension. Aware of tag tells your module that legacy UI module is supposed to be loaded. If the legacy UI model is not loaded, of course, where are you going to populate your pages in OpenMRS? Then you have required privileges. At least this module requires a privilege called view CommonLab tests. That's one privilege, but you have a whole list of privileges. Let me go ahead and show you. There are plenty of privileges for this module, if I'm not totally wrong. Yes, see, add CommonLab test metadata, edit CommonLab test metadata, add samples, edit delete samples, add edit or delete orders, add edit or delete or view results. These are all the privileges that exist within the system, but at least in order to access any part of the module, a user must have these A user must have this privilege, otherwise they cannot see anything in the admin list, they cannot see anything in the extension. Okay. And this is all committed. This was all part of legacy system where you had to define everything. Now OpenMRS uses makes use of annotations, Java annotations for a lot of things. Then we have these message properties files. So for this module we had English, French and Spanish. These three languages were supported, and then the messages file over here contains all the strings which are to be presented or translated. This is something we talked about yesterday, how messages work. Finally, we have a mapping file. Mapping file is a Hibernate XML file which is going to tell the module that there is a Hibernate file which needs to be executed. What Hibernate file, this file over here does is CommonLab test attribute. As you can see, it is going to create a new table called CommonLab test attribute table, and these are all the table columns and all. Now this is just one Hibernate file. There is more to it than just this file. I'll explain in a bit why there are two different Hibernate and XML liquid based file existing. But for now, the primary thing to remember is config.xml is the manifest. That's the file that OpenMRS reads and loads to wire the module into its system. Any misconfiguration in this file is going to break your module, not the OpenMRS but your module. Okay. Now this is this one I wanted to show you. This resides in OMOD. Let's now go back to module activator. There's a file called CommonLab test activator file, and this is extending OpenMRS's base module activator class. Now activator handles the life cycle of a module. There are life cycle hooks like started or shut down or refreshed, context refreshing. Global properties are created over here for this particular module if you want any, and of course you can see there are plenty of global properties we've defined, right? And over here, when the module is started, these global properties are set, checked for. If they don't exist, they are defined. Otherwise, API documentation, forget this, it's a warning. Otherwise you go on, you don't touch them in case there was an update. So as you can see, this module requires certain things. It says we have to have a concept to define specimen type. We have to have a concept to define specimen site, right? These are hardwired dependencies. Without these concepts, the module won't work at all. So that's one thing. So over here we have functions to set global properties, and then we have a shutdown, which is not really, we are not using this hook, but there is a context refreshed. Now every time a module is refreshed or any other module in OpenMRS is started or stopped, this is called. So every time the module is started or refreshed, you look for these global properties. If there's a directory, the path that has to be created, if it doesn't exist, you create it. Otherwise, go ahead. This is doing the same thing as started, only that the started works once and this executes on every specific change. Now we have this identical code because there's nothing new to be added when context is refreshed, but this sometimes is required, which is why these are two different hooks, right? So at activator handles the life cycle, and this one you will find in the API. Now this config, this is just a plain Java file. This is not a compulsion, this is not compulsory, this is not a dependency for a module. You can delete this file and still work or define these variables anywhere you want. So this is about the config file and the activator file. Now from here all the way to here, these 5 classes, these are defining the model. So this is an entity, we have annotated as such, annotation CommonLab test.lab test, and the table name is going to be CommonLab test underscore test. Now as you can see, this is an entity class called lab test. Actually, let's pick a simpler one, lab test type. Right? This is a metadata class. It will store what the type of lab test. Now if you go through this entity class, you will see that OpenMRS has made plenty of things quite easy. First of all, there's OpenMRS, and then there's also the matter OpenMRS alongside Spring framework. So Spring provides you, especially after Spring Boot, plenty of annotations which do a lot of work for you. As you can see, I have declared this as entity. This is a JAVAX entity, right? So Spring will recognize it as a class which is for ORM, meaning expecting a table against this class. So this class is going to contribute, is to be used as a skeleton to store data and fetch it, right? This is that entity. It is extending OpenMRS's own base OpenMRS metadata class. If I open this one, you will see that many of standard columns come out of the box. So name, description, creator, these audit fields, retired, retired by, retired reason, all of them you have it already out of the box. And then this is also in the hierarchy extending base OpenMRS object class. This is the class that's providing you UUID. Any object in the world of OpenMRS, any OpenMRS object, you will find it to be extending base OpenMRS object, right? And this is serializable, meaning all its children, every class that's inheriting it is going to be serializable. That's a very important point. You may explore this further. What are these annotations? What do they do? This is all advanced OpenMRS stuff, but for our purposes, the scope is limited over here. We have OpenMRS metadata, base OpenMRS metadata, which we can extend, and then base OpenMRS data. So there's metadata and then there's data. I'm going to show data as well. The difference is that you have audit fields, and data classes are voided and unvoided. These are not retired, right? These are also extending base OpenMRS object. So OpenMRS gives you these entities to extend and create your own. Now all I need to do is to just look into what more fields I need. So I'm going to need lab test identifier, right? I'm calling it test type ID. I need a short name for this test. I need a test group, which group does it belong to, and this is actually an enum. So a lab test might be, think of it as the department that is processing that lab test. So you have biochemistry, you have radiology, you have microbiology, you have bacteriology. There could be 2 or 3 departments depending on which one you want. That's how you configure the lab tests. So or you may pick just one or other. This is not like it's not hard binding any logic. Now once you have test group identified, you have requires a specimen. This is telling you if to perform this lab test you require a sample. It could be blood sample, it could be bone marrow, it could be sputum sample, whatever. Basically, do you require a specimen? So for example, in audiometry tests you don't need one, in radiology tests, x-ray, you don't need one, in ultrasound you don't need a specimen. So there are two of these types of tests. And then reference concept, its data type is concept, meaning which concept in our concept dictionary is going to represent this lab test type. So these are the entities, the rest is quite standard. These are getters and setters. Now you can see, in order to make one column auto generated, you are just declaring an annotation generated value, identity, meaning this is going to be identified auto generated value primary key, and also it is an identifier as annotate. Then we have a field, we have a column, short name, this is going to be the name of the table. The length, allowed length is 50, same goes with test group, allowed length is 50, and requires specimen is not nullable. By default we are setting it as false. And then we have reference concept, which has many to one relationship with the concept table. So this is how we are going to define an entity, a custom entity which did not previously exist in the OpenMRS schema. Now we have defined these entities here in our code. So we have lab test, we have lab test type, we have lab test sample, and you will also notice the lab test we have defined as attributable. All we need to do is to extend the base customizable data and provide the attribute, and then that's it. The OpenMRS takes care of everything else. It knows how to make a certain entity attributable. So you can explore this really advanced stuff in Java. Hydrate, serialize, this is an interface by the way, and then this base customizable data class, you will see that how it handles collections, how it constructs table behind the scenes. That's your attributable feature from OpenMRS. So you don't have to do a lot. Now in lab test you will see these further fields for the lab test, and then there's sample. Samples are set. So for one lab test you may require multiple samples. Even for smear microscopy there are 2 samples. One is a spot sample and then another morning. That's how basically. Same goes if you are for blood sugar as well. There's random blood sugar and then there's fasting blood sugar. So there are tests which require more than one sample, which is why this is a set. Now the sample itself in this module follows a certain life cycle. Actually we'll come to the life cycle afterwards. Let me just go ahead and show you another aspect. Now that you have the entity defined, how are you going to tell that OpenMRS to create tables against this entity? This is similar to migrations in Django. For that OpenMRS uses Liquibase. Earlier OpenMRS used a tool called SQL diff. There was a library, and later OpenMRS upgraded to Liquibase. Now Liquibase this file here, liquibase.xml. This gets executed when the module is being started. So the first time module starts, Liquibase checks for this file and looks for this change set. If it has already been run, it is going to mark it as ran if one already exists. Remember, we just resolved an issue with the Liquibase lock, and that was Liquibase locking a table. So this is Liquibase. Liquibase maintains a table, a trace of all the changes that were executed, that were applied to the database. Remember, we don't make any changes to a running OpenMRS schema on SQL level. You will always be writing these files and making alterations to the schema wherever required. So right now what this file is telling you, is telling Liquibase to create this table called CommonLab test type, and then create another table called CommonLab test attribute type, and another table CommonLab test, right? And all these tables and the data required for them, the privileges required for these tables, all of it you will find over here in Liquibase. So Liquibase is basically SQL represented in XML. That's how you can view it. Now why we have XML? Because it is compatible with plenty of other databases. So we are not going to write MySQL script to create tables or alter them or insert certain data inside them. We are going to use XML so that any other database can be used later, and the same changes will be applied. Here we are adding foreign key constraints. There's a syntax to be learned about Liquibase that you have to go through the documentation to properly understand how these changes apply. And see, there is renaming some tables, renaming column, whatever you want to do. You never go back. Actually, if you did something and you want to alter it, then you append another script to make that alteration. So for example, if you created a column called short test name, and now you want to rename it to short underscore name, you are not going to go back and change the script from previous date. This change set maintained by date, you're not going to go back in time and change the script. You are always going to go forward, create a new change, and then rename the same column. That's how it works, right? I believe we are also entering some data. Yes, for example, look into this change set. Here we are checking a precondition. We are saying basically run an SQL query and see if there is a concept with a short name unknown lab test type. If one already exists, then skip. Otherwise, insert this new record into that table, into concept. So we are creating a new concept because this concept is compulsory for OpenMRS or for this module to work. Now look at this UUID. This is where you will I will make you take notes. Take note of this UUID. This same UUID can be found where was it? Actually, let me just search for it. It will be much easier. Liquibase, copy, Yes. So we are updating the reference concept wherever we have this UUID, because this is the UUID for unknown test type. So you have to have at least one test type to run this module, and that test type is going to be unknown. I'm trying to find where else this UUID exists, because there are two places where we've defined the same UUID. What we are saying here is basically this is the UUID exactly that's being used to mention an unknown type of test. That's one entry that's required in the table. Other than that, you can use any other UUIDs as well. So these UUIDs were generated bearing in mind that they don't conflict with any other. Moving on, all of these change sets you can look into one by one, and you can also find the trace of all changes. When was a particular change applied, right? So that's the schema for lab test module. These are the new tables that are going to get created inside OpenMRS database once this module is deployed. And also, once a table is created, it stays there. Even if you remove the module, you delete the module, does not mean you will also delete the tables. The tables will continue to exist there. Right? Okay, so we've covered the entities and we've covered Liquibase. Now let us talk about what resides at the heart of our code. In the API package, you will find DAO and service implementation. So let me first explain what DAO is. Data access objects. First of all, you are going to notice an interface. This interface is telling the methods that are required by our module are listed as below. None of these methods are implementations, they are just declarations. So there is going to be a method to get all lab test attribute types, get all lab test types, get lab test types by these multiple parameters, get lab test, all these getters, and that's basically an inconsistency. Yeah, we need to fix that. So these getters, and similarly you will have more save options too. So save lab test type, lab test sample, save lab test attribute type, lab test attribute, and save a whole lab test. This is recursively going to store the rest as well. And we also have purge. Now this is that particular module in which we required purge. Purge meaning hard deletion of data. Although these purge methods were not exactly called, but they were still created based on the requirements we had. So we still went with the soft deletion, but the term OpenMRS uses to hard delete a record is purge. Purge meaning the record's gonna go away from the database. This all came from after the era of GDPR compliance. So we do have now compliance requirements which may require our database to actually physically delete a record of a patient. So if a patient requests, I want my data deleted, you have to delete the data. You can't just soft delete it. So these were the kind of features we required later. Now this is only data access object interface. the implementation of interface can be found over here in the implementation package. Now here you will see that the test DAO implement class implements the interface, and now we are completing all the methods. This is our data layer. So to save lab test type, this is your parameter, session factory gets called, you are calling lab test type. If a record already exists, it will get updated, otherwise a new record will be created. So the method name is literally save or update, one method for both update or insert. And you will sort of follow all of these. So for example, lab test order, we are creating a new order for this lab test because order is OpenMRS's own entity. So we are calling the order service, OpenMRS's order service. You can look into this context.get order service.get order, and then from the same service you might create a new order or save an existing one based on whether you are creating a new or updating. So this is about saving an order. What if we wanted to purge something, delete something? We have also provided those options to delete, and it's going to recursively delete all the all the data dependencies. You can also look into get n lab test samples. N is the number of samples to fetch, and we are providing patient lab test status to search, first n objects, last n objects, include voided. This is fetching the lab test samples against a patient based on the criteria you're providing. So we have created a criteria query. You can see the inner joins over here, a join with lab test order, the OpenMRS's order table, and then order.patient.patient ID is going to map with the patient ID from the incoming parameter, and whatever field you are providing, it's going to match and return a final list. Right, so this is one example where you are running a criteria query instead of plain old SQL to fetch data. Same goes with other methods. This really requires some exploration, how OpenMRS data is stored, how these methods are created. You can basically follow what's already there, but for OpenMRS, for the MDR-DB module, you will see a few differences. Similarly, this is a search method, get lab tests. So whatever parameters you've provided, lab test type, patient, order number, whichever you have provided that are not null, are going to be added to the criteria, and finally you will get a list of lab tests based on your criteria. So all these helper methods that interact with your data, you are going to provide in your DAO, which holds all your data logic, right? Now this is about the data logic itself. Now moving on, after the DAO package we have, let me actually go back to the outlines. So we have domain, which is basically the data layer, all the entities, entity layer, the model. Actually, let's rename it to model. Then we have data access objects, DAO, and now we are going to talk about service, the service layer. Service layer resides in the API package. Now when I say service layer, right now we only have one lab test service class providing all the service methods. We have annotated this class as transactional, and its respective implementation will be annotated as a Spring service. Now let's look into the service class. How is this class any different than DAO? See, DAO implements, in DAO you write your data logic, how to retrieve data, what rules to, what validations to apply, how to delete it or fetch it. The service is where you apply your business logic, how your module wants certain things to be done. Sometimes, actually more than often, you will find that okay, it's basically the same function calling another function from DAO. It's literally drilled down, but it's how the design is. OpenMRS, and it's a really clever design in layered architecture, so that you are able to change anything in any layer based on where it belongs, where the change belongs. This also keeps your entire module testable. This enables you to locate the bugs very quickly, and I can see many inconsistencies, by the way, in the documentation, which is weird. Yeah, you don't have these often in OpenMRS. Now you can see there were no methods to void or unvoid anything in DAO. There was purge, but here you see retire and unretire lab test type, void, and also then unvoid. Now this is an interface. Let me go towards the implementation. This over here is the most important class of this module. Okay, this doesn't exist. It's fine. So, anyway, let's go ahead. Service class is extending base OpenMRS service class, and this already resolves plenty of problems for you. So you have a whole life cycle, the context and all. So this is OpenMRS service, and it's being handled. Don't think of these as dumb classes. Everything is being handled using AOP, and I will come to that. There's an example of AOP. Now the first thing I have declared is the DAO object. This is auto wired, meaning I don't have to take care of its life cycle. I don't have to instantiate it, initialize it, or destroy the object. There's just one object. Spring is going to take care of it. How Spring is going to take care of it? How does Spring know what classes do I need to take care of? That's where you go into this. Where's the implementation? Yes. So this is declared as the implementation is declared as component. This is a component. OpenMRS now knows, okay, I will scan the whole code for all the components, all services, all entities, all transaction classes, and take care of the initialization. Now you can look into, I will also show this one, but just giving you a sense of what's happening. So auto wired basically in Java means OpenMRS, Spring is going to take care of the life cycle of an object. Now this is manual injection. You may forget this for now. Look over here. This method is overriding from the parent class to the interface, and I have first tag as authorized, meaning who is going to execute or call this method. Whichever user made this request must have this privilege, otherwise an authorization exception will be thrown. That's literally what this annotation is doing. We don't have to do a lot. OpenMRS is we just need to provide the right privilege and annotate the method with it. OpenMRS itself takes care of the authentication. So if I have a user which accidentally calls this method and does not have privilege, an exception will be thrown. Similarly, this is transactional and read only. By read only, you are telling Spring that there will not be any data changes performed under this function, in the body of this function. So OpenMRS has to the Spring cleverly looks for such traps. If you are saying read only is true, and then if you try to make any changes, try to push any changes, that's where you get an exception. Similarly, if I go into further, let me pick something. Yeah, this one. Get earliest lab test sample. So earliest meaning you are going to get n lab test samples, supply 1. You only need one of them and return the first object you get. There's just going to be literally one object. Similarly, if I go ahead and try to show some other method which is actually implementing some depth of logic. Okay, here get lab test types, and if the specimen is required for that lab test, if it's passed this parameter, then only return the lab test which for which a specimen is required. Right, this is what it's doing. And okay, save lab test. You will see this to contain some checks. For example, if you are supplying a lab test which does not have an order attached with it, you will get an exception, because in order to create a lab test you have to have a one-to-one relationship with order column, order table. If you don't have an entry in the order table, well, this lab test cannot get created, which is why there is this exception being thrown. Same goes with encounter. Encounter is required, concept is required for the order, and who was the provider who ordered this lab test, that's required. Same goes with lab test samples, adding lab test samples, adding attributes, and then saving the lab test object altogether. Right? Let me give you an example of So we have retire lab test type and unretire lab test type. Say you soft deleted or deactivated a lab test type, and now you want to bring it back, you have to provide a reason. Sorry, when you retired it had a reason, you can bring it back. So OpenMRS does support, because it's a soft deletion, you can bring back those rows you have deleted. Okay. Let me see if there is anything advanced going on here. Delete lab test. Handle lab test type dependencies. Yeah. Okay, there's one more thing I wanted to show you. This is a very simple version of a service class. The CommonLab test module itself is quite simple to understand and work on. I am going to go into DAO if I have it. Actually, I don't think I have the DAO. It's in it may be used in the MDR-DB module. If it comes to it, I'm going to show you that. Now let's we've discussed the service, we've discussed the data layer, the service layer, the model layer. So starting from model, the next thing is data, the one after is service, and now we are going to jump to the controller layer. As you can see, this falls into the OMOD project because this is related to web interfacing. Now external systems we are talking about the communication with external systems and external objects or entities. Let's say we have a form called lab test sample. You see there is a controller which binds lab test sample objects with lab test sample form. Let me go ahead and show you what I mean by that. So there is add lab test sample form. This is a JSP form. As you can see, plenty of code was required. You are going to write plethora of code to create just one form, and this is only for lab test samples. There is another page which is managing the list of all lab test samples. So these are two different pages, and every page has a dedicated controller against it. So manage test lab test sample has a controller, and then lab test sample controller which is adding lab test samples. So this show form provides the data in the format you need it in, and you can see there's plenty of boilerplate code. Back when we used to work in this manner of legacy JSP pages. Now compare this with what we do now. These are basically, you can read and try to understand how OpenMRS's legacy UI worked, but this is not again part of our scope, and we won't even consider anything as such in the future as well, because OpenMRS has completely phased out the legacy UI too. So nobody is now using JSP pages for any new projects. So we are now interested in this resource package. This will do exactly as it is saying it will do. This is your REST API endpoints, the collection of REST API endpoints for CommonLab module. Let's open again lab test type resource controller. Now you will see in the header, first of all, how is the resource going to be called. So you will see slash CommonLab and then slash lab test type. Remember Postman? You can write something as like lab test, sorry, common lab test type. Okay, I did not have session, now I have session. Now let me explain this. As I called this API endpoint, what happened? You can see all the lab test types are being returned. Unknown TB test for MDR-DB. That's just where we are. Now let's go back to our code. What just happened is I called this endpoint and I am calling what? It's getter. So what I did is call this one do get all. Since I am not providing any parameters, I am not providing any UUID here, OpenMRS already assumes that we are actually calling this one get all. So without any further extensions, get all is going to get called. This request is going to land over here. This page, this function is going to call get all lab test types method of CommonLab test service. This is going to call, let me go to the implementation. Yeah, this service method is going to call the get all lab test types of DAO, right, over here, and the DAO is what is going to talk to the MySQL database and return these records. This is the chain that's being followed. So as I receive a list of lab test types, what's happening over here is also interesting. See, this lab test type is not going to be returned as is, because this is an OpenMRS object. This is not a plain old Java object. So some sort of representation is required. And what is going to be that representation? You're going to find that over here. Get representation description. This is where you will see the real power of OpenMRS. You see this V is equals to representation. If the user says representation full, what are the fields you are going to return? I am going to return test group, short name, requires specimen, name and description. If the user says if the representation is default, then these. If the representation is full, then I am also going to include audit info and any other columns I may be leaving behind. And if it's only about reference, then I'm going to only return name and test group. Now you can see I have name, test group, links. Let's go ahead and do this. Now you can clearly see I have all the fields available. So what just happened is, this is all OpenMRS magic. I am not saying explicitly for every entity what to do. I have two methods. I overrid them and defined the properties I wanted, and then that's it. So if I have a representation, I am going to return whatever I want. Now let's have a look over here. Creatable properties. Whenever you are creating a new object, if you are making a new post request and providing data in body, then what happens? Then these are the creatable properties. OpenMRS requires you to enter all compulsory columns, but that's the only acceptable objects you can pass on. That's the only properties you can pass on. So in your JSON object, you may have name, test group, lab test type ID and all. This test group must conform and be convertible into the test group enum, which we have defined in the model. That's also something OpenMRS takes care of. So all of this, where exactly is this functionality happening? We are literally writing a wrapper. We are not providing all of this implementation. So what's happening is, here I have extended my class using metadata delegating CRUD resource class of OpenMRS, and this is handling the metadata, not the data classes. We'll come to data example as well. You see it already has a bunch of defaults. So UUID, display, name, description, retired. It already knows that these fields are going to be there if we are talking about metadata, because every metadata class has to extend the OpenMRS metadata object, metadata class, right? So that's where all the magic is wounded together. convert to ref as default representation, as full representation. Delete, it already knows when we say delete, we are going to set retired as true. We are going to set retired as the authenticated user, the user who is connected to this the session that is being passed. The user who has that session is the one who's authenticated user. He is the user who deleted it, and set date retired automatically. It was retired right now, and then that's it. You can't change it. Retire reason you are going to supply. Why was it retired? And then there's localization. If you have different locale, then this takes care of that. The messages dot properties file, all the messages are going to get translations from this. You can see localization, get message, source service dot get message and message code. So any code that's passed on, the localized version of that code will be returned. Okay, and this is just one part of the functionality. This abstract class itself is extending another delegating CRUD resource, and this is, you can say, this class is like marvelous. This is where you actually get to see how good OpenMRS development team is. So they have constructed this whole convention of writing code which allows a developer to simply extend an existing class and already make use of more than half the functionality. If there is anything else we need to define explicitly, only that part we are going to write, otherwise everything is given. That's the beauty of OpenMRS, of using OpenMRS's foundation module to develop anything. Now compare this with something like creating your own project, interacting with the database directly, and providing a REST API. That will take like a year to build and test and like try and trust in all. Okay. So we've covered a bunch of examples from OpenMRS's CommonLab module. Let's say I wanted to make certain change in this module now. Let's think about a change. Say we have lab test sample entity, and in lab test sample entity we want to add something. Let's say we want to add a place where this lab sample was collected. Okay, meaning the facility itself. Now lab test sample can be collected in a certain facility. It can also be collected in field. So what we are going to do is we are going to put in a nullable property, and let's just name it collection point. But this is not going to be a string, this is going to be a location object of OpenMRS. As you can see, I have defined it. I haven't declared any getters or setters, so I'm going to write getter setters. And then let it autocomplete. I have a getter, I have a setter. Good. and now I have to use them somewhere. Where am I going to use them? I'll go to web resource, and in the sample I will add this as another property. So my variable was collection point, and as soon as I add just this, oh no, there's one more thing I forgot. I have to go to Liquibase and add a new column here. So let's pick something like this, and we are going to add another change set, and we are going to name it 2026-07, and this is the first change of today. Author is Hussain. In the lab test sample, if I have collection point, underscore point, then skip. Otherwise, in the same table, create collection point. You have created a collection point, yes, but there's one more thing to do, which is creating a foreign key relationship. I'm going to add this into the same change set. We need to create a new one, and let's call it location sample, and base collection point, referencing location, and this is going to be location ID. That's it. So now I've made this change, and I'm not going to rebuild and make changes to the existing server, because it's running it, the trainings are ongoing. I don't want to break anything right now. The point is these are the steps you needed to take to make that change happen, to add that change. Now this is not enough, it's not sufficient. You have to go to tests and write tests, but first you'll have to think about what tests do I even require. Do I even need this functionality to be tested? Do I need to write an additional test just to make sure that the column was added or not? Does this belong in the API or in the OMOD? That's a $1 million question to ask. So this is part of your collector. Yeah, this is part of your REST API, right? So I am going to put in collection point, but the parameter must be a valid location. Without this, of course, there will be a foreign key check issue. So I'm going to go into CommonLab test service dot initial data. Let's see what this is. This is a file which contains a whole data set for testing. It's an entire data set only for testing. So whenever our tests are executed, they make use of this file. However, having said that, this is not the only data set that's available for testing for you. You see, since we are making use of OpenMRS itself, you can add OpenMRS's own test suite and make use of OpenMRS's own data set for testing. I just have one more file to show to you. This is basically all covered, everything I've explained in a module. This, however, this was left out. So what is this? Module application context.xml file. You see this line called context component scan base package. This is going to tell OpenMRS to look for all the classes in this package which you are using Spring's annotations. Actually, this is a Spring feature. You're telling Spring to search for all classes which are annotated as transaction or as component or as service inside this package, and wherever they are being used, they are going to be auto-wired, because now now the Spring framework is taking care of the initialization of objects, the life cycle. So you don't need to create the same object over and over in multiple classes. You just have one instance and that does the job for you, and that instance is been taken care of by Spring. That's one thing. Then we have these properties, these beans defined. So here I am defining what the module service layer. It's there's a transaction manager which will be used in CommonLab service, right? CommonLab service also has a target implementation called CommonLab test service IMPL implementation class. There are interceptors if we are using aspect oriented programming, but we are not doing that. So these are a few properties we are defining. Now in current module you won't find them, because we have updated the MDR-DB module to, and even this is not required. This is no longer required. So you will find a blank, almost an empty file in module application context, because a lot is happening from the code level itself. But it's important to understand this particular file. It exists here as well as in the OMOD. Now OMOD I don't have a lot because I don't need a lot. I'm just telling it where the controllers are. That's it. Everything else is taken care of. They are annotated. So I'm not expanding. I'm not providing any logic. I'm not implementing any data logic or business logic in my OMOD. It's just to pass on the data, receive the data, and call the right functions. That's it.